Hi everyone, welcome to the session. Okay, so in this session, we are going to learn about design patterns in Python. Okay, so what are design patterns in Python? Design patterns in Python are reusable solutions to common problems that are encountered during software design and development, and these design patterns represent best practice for structuring the code, improving the maintainability, scalability, and efficiency. Okay, and coming to the categorization of the design patterns, or you can say the types of design patterns that we have three types of design patterns. One is creational pattern. Second is structural pattern, and the last one is behavioral pattern. Okay, so talking about the creational patterns focuses on the object creation mechanisms. It aims to optimize flexible and controlled way to initiate the objects. Okay, and then talking about the structured patterns. These structured patterns deal with the composition of classes and objects, both the things, following on how the objects are assembled to form the larger structure. Okay, and few of the example are adapter, decoder, and then coming to the next one, that is the behavioral pattern. Now, what are these behavioral pattern? These behavioral patterns addresses the object interaction and communication, which focuses on how the objects collaborate to achieve a goal. An example of this is observer and strategy. Now, coming to the coding part of the creation pattern that we have, the singleton. Okay, so here you can see we have class singleton instance equals to none. That means the class variable where we have stored the single instance. Okay, and then we have this function as new, which is a special method used when creating objects. Okay, and then we have create new instance. We have created new instance in this line, and in the last we have just typed print create new instance, which will display the message, and then you have written the function. Okay, and then when you just run this, it's done. And then you have next as the testing singleton. Now, what is this testing singleton? Let's test it. Okay, so we have just created object one, and we have assigned it to singleton, and then we have another object created here, which is singleton. Okay, we have two objects. One is object one and another is object two, and after this we have something known as print both the objects. Okay, print both the objects are same or not. Okay, let's see if both the objects are same or not. When we just run this, you can see that we have got the answer as creating new instance. Are they both same or are they both same objects? The answer is true. Okay, the objects that we have created, both the objects are same. Then talking about the creational pattern. Okay, creation pattern. Uh, Factory pattern creates the objects without exposing the creational logic. Now, talking about this, in the first function, in the first few lines, you can see that we have written a code that is common method to be overwritten by subclass. Basically, these all things are just like thing. Okay, and these all things can use it further whenever we want to just use them. When you run this, you'll get this. Okay, and then you will just run this, drawing a circle, and then you have drawing a square. And when you have this factory class, you can see we have written class shape factory. Then we have a function get shape. Get shape is a function that we have used here. So get shape and self comma shape type. What is the shape type? We'll get the shape type. Okay, the shape type is circle, and then the shape type is square here. Or else we can see that we have this conditional statement, and both we have using this conditional statement, and we are defining a function. We are defining a function known as get shape. Okay, so when you all together run this, what do we get? We get this. We get this particular out. Coming to the next part, we have the testing factory. Okay, we have written the code. Everything is done. Now just let's test the fact. Okay, so we have this code factory equals to shape factory, which will create factory object, and then we have a variable known as shape1, which we are just assigning to factory dot get shape function. So get shape function is what we have created here. We have created here the get shape function. Get shape function of what? Of circle. And then we'll print this. So let's print this. Okay, what is the output that we got? We got the output as drawing circle. Next, we have shape 2. Okay, in shape 2, we can see we have used here. Now, when you just run this, what is the answer? Name 2 is not defined. Okay, so maybe um we have just missed this S in shape. Okay, so when we run it properly, we get drawing square. Okay, and the third type that we have is structural pattern, that is decoder, which will allow adding new functionality without modifying the existing code. We can add new functionality to the code without just creating a new one. Just these all things are just like the templates that we can use. So we have here a function known as bolt underscore decoder. Okay, and here we have defined it. Let's run it. Okay, and then we have another function which is italic decoder. So let's even run this italic decoder. So this is what we got. This is what we got. Okay, now let's just run all this thing and see. Okay, so see, without doing any changes further, we have added few of the functionalities in the function. We need not to do much over here. We are just adding few new one from the scratch. Okay, and next thing that we have is the behavioral pattern, that is a observer. One to many dependency we have. When one object changes, the other will get notified. In the allowing adding the new functionalities without modifying the existing one. But here in the behavioral pattern, we can see that when one object changes, the other will get notified. Okay, so see, we have this class main subject being observed, and then when we are just running this, okay, we have just run this and we got this part, we got this part in our console. And then when we are running this class observer define self message, okay, let's run this. We got this output, and now let's test the observer. Okay, so when we have this test observer, we can see that just just having this subject as a variable, and in this subject we are creating an we are just creating an subject. Okay, in the variable name as subject, we are creating a object known as subject, and then we have another one as observer, which is obs1, and we have another object that we have created obs2. And you can see here we have observer as an object. So moving to the next one, we have subject dot attach observation one basically. So obs one, and then we have subject dot attach to obs two. Okay, so when we run this is all code that we have, it will give us the output as it will give us an output as received design patterns are powerful. Received design patterns are powerful. Okay, this is what we got. This is what we got because you have this notification, right? We were telling this that when one object changes, the other will get notified. So this is what the change we saw here. Now this was all the coding part, but if you want to further know the examples of few of the types or the categories of the design patterns, so talking about the creational patterns, we have the example of singleton or the factory method, and then we have this abstract factory, then we have builder. These are few of the things that comes under the creational patterns. Then talking about the structural patterns, few of the examples would be adapter, decoder, composite, proxy. Okay, so these were few of the examples that we have of structural patterns. Now talking about the behavioral pattern, we have few of the example as follows, that we have the example as observer, strategy, command, iterator, state. So these all are the example which comes under behavioral pattern. Okay, so this was all about the design patterns in Python. I hope you all understood it, and happy learning. And thank you for joining this session.